Now that I have your attention, what's it going to take to improve 311 call service for Washington, D.C. in 2021? I'm Michael Goddard. This is going to be fun. Let's get started. The call service coverage area for Washington, D.C. consists of about 68 square miles with about 285,000 calls analyzed in 2020. As we overlay the map, we can see the number of calls, the open days, and the zip codes for the various areas in the district. So where do we focus our energy in 2021? We could reduce the number of service requests, we could reduce the response times, or we could do both. I focused on using a k-means clustering technique to group the service calls based upon the count of calls and the number of open days. This formed a number of clusters that we could use to group the data so we could analyze the information further. Here are some details on the inputs for the clustering displayed on the screen. By highlighting the various cluster names, we can see the various data points on our scatter chart that make up our metrics, and we can also identify outliers. Outliers are important to understand when considering our metrics. For example, we could see a lower demand, worse response outlier, and we could see our higher demand, better response time outliers. For example, DC government information requests totaled 11,537, yet the number of open days was 0. From this, we can infer that this service is not labor intensive. In contrast, calls for roadway signs totaled 5,736 with 108 open days on average. We will use several services from the center of our 311 call center universe to validate a trend forecast model. Next, let's review the trend forecast model using a handful of our services having average demand and average response times. This trend forecast model was developed using analysis of service call data over a 52-week period in 2020. This graphic displays a select set of services from our clustering classification effort that are representative of average demand and average response times. Since most of the observed calls have peaks and valleys for call volume and response times, a polynomial trend line was used to identify trends over time. Since call volume and average response times may not have a strong correlation, this is a more effective technique than using a linear trend line. Note that the quality of the forecast model is poor for two of the services, SuperCAN delivery and street cleaning. This could be due to a lower observed data points, surges in call volumes, or other factors too numerous to mention here. Further analysis is warranted. The forecast model quality for two of our other services, street pruning and private property inspections, look good with acceptable root mean squared errors. In general, a root mean squared error of 15% is considered good in predictive analytics. We use this information to our advantage shortly. Next, let's try to understand our problem children identified earlier. DC government information railway sign requests. As I play the next animation, watch how the number of open days remains at 0 for DC government information requests and how call volume for roadway signs increases as rainfall totals increase. High volume and 0 response days can skew our key performance indicators and mask poor response times for other services. For roadway sign requests, we should look for ways to get in front of demand for this labor-intensive service as rainfall totals increase. Lastly, let's deal with our bread and butter service calls, average demand and average response times. These are at the center of our 311 call center universe and part of the forecast model we created earlier. First, look at the spikes with our private property inspection services past year. In July, we had 71 calls in one day. We need to understand if this was an anomaly or something we need to be concerned with. Did our customers experience long call wait times that day? I certainly hope that was not the case. On December 23rd, when staffing levels are typically lower due to the holidays, we had another spike of 57 calls. Are we staffed to handle these spikes? This is where trend forecasting can help us plan resources effectively. By understanding the trends, we can properly staff our call center to handle the volume. Now onto one of my pet peeves, really long service response times. In this case, for a tree pruning service. In March, one of our service calls closed after being open for 338 days. 338 days? This is unacceptable. We need to figure out what's going on with these requests and how to provide faster service to our customers. We need to understand why the service request took so long to close and if this was an indicator of a systemic problem. As if the March spike was not enough, we see another spike in May of 154 days. If this was your mother calling to have her tree pruned, would you be happy? We can and will do better in 2021. In conclusion, using time series forecasting, we know where to focus our energy in 2021. Trust but verify our trend forecast. We know which problem children to fix. We need to focus on our bread and butter to handle call volume better and reduce response times. Now that we have our ducks in a row, let's get to work.